Hello everyone, my name is Ruth NDuta, a data scientist come machine learning engineer, and I'll be taking you through the BERT session. I hope you get to learn a lot and enjoy. I'll start off by, I'll assume that you already have your data set pre-processed and cleaned. So I just want us to focus on building the model, talk about BERT, talk about transfer learning, and see how you can use this to create predictions on your own data set. So the first steps in my approach as I was learning BERT and doing all this, at first I decided to use supervised machine learning, incorporate SVMs, KNNs, just to see how they perform against BERT, and then compare BERT's performance to the transfer learning approach that I'm going to show you as we continue. So kindly just allow me to go really quickly through the first bit, where I first loaded my libraries, loaded my data set. You see, I had already pre-processed my data set, prepared, did some EDA, did a little bit of cleaning. So kindly allow me to rush through this bit. Split my data set, so these are the classification models that I use for supervised learning. Made predictions, yes, checked. So these are the accuracy metrics that I used for the supervised learning, for the BERT model, and also for the CT-BERT model. Now, accuracy, which represents the correct classifications over the total number of classifications made. Now, precision measures, this metric quantifies the number of positive class predictions that actually belong to the positive class. So out of the positive class and the predictions that are made, how many are true? So recall then quantifies the number of positive class predictions made out of all the positive examples in the data set. So remember, precision, number of positive class predictions that actually belong to the positive class. Then recall, number of positive class predictions made out of all true positives plus false negatives. Yes. I know we know about this, but I'm just trying to put some emphasis on it. Then F1 score, because it concerns both the precision and the recall. You'll see that as we go on. So I made the precision, I made the confusion matrix here, and then calculated the accuracy and the F1 score. So you can see for the supervised machine learning, these are the accuracy scores, 0.65, okay? Now, I'll come back to this once I have done BERT, but let me just go through transfer learning. So we all know of deep learning and neural networks, which have the input layer and the output layer, and in between the hidden layers where everything happens, all the conundrum. Now, instead of us trying to train a new model, there is existing models out there that big organizations with bigger machine and bigger computing power have done. And some are open source, so you can take them. Instead of training your own, implement the model to suit your domain. That is what transfer learning is all about. So one, you use an existing language model that has been trained on lots, usually tens or hundreds of gigabytes of data, of text. So this results in a language model that understands the roles of the model, because for your model to really understand a language, you have to train it for hours and a lot of epochs. So why go through that hassle if the guys who've done this for you? So the next step, you have to fine tune. This is where you take the language model that understands in a more general sense and adapt it to your particular domain. Now, in our case, COVID-19, because I'm sorry, I forgot to introduce my data set. This is a previously I collected data on using the Twitter API on some tweets, and that's what I'm working on. I want to look at the sentiment on COVID-19 related tweets. So once we have a fine-tuned model, we can use this to initialize a classifier to predict the labels on the sentiments, okay? So that is what this session is all about. Now, unlike the supervised learning approach above, in this case of transfer learning, we want to work with text, which has not had stopwords. So remember, for supervised machine learning, you have to do a lot of cleaning. I actually didn't do enough cleaning because that was not the main focus of my session. So, but then for BERT, you really do not have to remove the stopwords because we want our text to be representative of normal language and process the same language structure and rules as learned by the language model we will use, okay? So we can once, sorry about that. So I'll just skip over to using BERT. So I know I've said BERT a lot. BERT means the bidirectional encoder representations from transformers. Bidirectional, why? Because unlike the supervised machine learning models, which read or rather digest data from left to right, BERT can ingest data in both ways, both left to right and right to left. So that's what makes it bidirectional and can therefore read words before or after the word in a sequence. So it can either read words from behind or from the front. So BERT language is trained on a large amount of data, all from Wikipedia. And in case you need more information, there's so much information about BERT on both Hugging Face website and different publications and blogs. We are also going to use the Simple Transformers library, which is a great tool and for quickly and efficiently utilizing machine learning models for transfer learning. So simple transformer models are built with a particular natural language process in mind. Each such model comes equipped with features and functionalities designed to best fit the task they are intended to perform. So in this case, ours is classification, because we are doing a sentiment analysis to classify the tweets as either positive or negative. Okay, so remember, first we're building a BERT model. So we specify our model's parameters, then train the model. And then we created so we need a wrapper function, because a wrapper function is a simple utility that allows us to modify an existing function. So in our case, we modified the metrics that we use, remember the accuracy, the F1 score, so that it can be utilized by simple transformers. So that's what we created. And you see we get an F1 score of 0.866. Remember from supervised machine learning, we got an accuracy of 0.6555. The accuracy has drastically improved to 0.8669. Again, we do the classification report. Now we can put that in our data. So that's the BERT model. Interestingly, researchers from the Digital Epidemiology Lab in Geneva, Switzerland, have trained a language model based on large amount of COVID-19 related tweets. So instead of creating a language model that learns about text from articles in Wikipedia, aka BERT, now we can implement a model that was trained on COVID-19 tweets, which has the same architecture as BERT, but that only understands the use of language as it pertains to tweets related to COVID-19. So remember the first bit we were using BERT, which is a bit general. It was trained on Wikipedia. Now, guys in Geneva did same structure, same architecture as BERT, but then on COVID-19 tweets. I accidentally ran this cell, but I hope we get to see the answers. Should have shown me. About that, I had to reload my data set. So we are doing the city BERT, which is the COVID treats BERT model. and check the performance, how it performs, how the accuracy improves or does not improve compared to using the BERT model that was just trained on general data. So again, I specify my parameters. And then get my F1 score. So you see, the CT-BERT gives us an improved, more improved F1 score. The previous one gave us 0.86. This one gave us 0.87. Of course, we can make it better, do a lot of hyperparameter tuning, play around with the different parameters, do some cross-validation just to get a feel of the best parameters that we can use, just to tune it. So I omitted all that out so that we can save on time. Then I had to use now the CT-BERT that has already been familiarized with my data to make new predictions on unseen data, because that was the main reason for the hackathon. So you bring in your trained CT-BERT model that is already familiar with your local data and the data that I got from Twitter and the sentiments that I got from Twitter that I'm trying to classify whether positive or negative. Okay, I did not want to run these cells and just show, but as you can see, it did the classification. And I hope you guys learned something from my BERT session, especially on deep learning and especially on transfer learning, and that you do not have to train your models from scratch. You can employ all the models that exist out there and bring the same knowledge to your model just to familiarize that with your domain. And especially with BERT, the Hugging Face website gives a lot of info on that. And I'm sure that you can learn a lot from just going through the material. That is what personally I did. And you get to build amazing tasks, whether it's text classification, text generation, masking of languages. They also have the computer vision, speech recognition. The possibilities are endless. Thank you, and see you soon.